What if I told you that nearly everything you think you know about space is wrong? That the dark side of the moon isn't actually dark, that astronauts don't float because of zero gravity, and that black holes aren't cosmic vacuum cleaners. These aren't just harmless misconceptions anymore. They're actively spreading faster than ever thanks to social media. In 2025, with over 300 launches planned and private space companies making weekly trips to orbit, these myths have real consequences. When SpaceX is launching tourists and NASA is planning Mars missions, it's time we finally killed these misconceptions once and for all. Some of these myths are so fundamentally wrong, they're going to need our most powerful weapon to tackle them. The Aristotle scale returns, rating 2025's biggest space myths. We're bringing back our trusty Aristotle scale of wrongness for 2025, and honestly, we need it more than ever. Just like before, we'll rate each myth from 1 to 5 based on how fundamentally wrong they are. A 1 Aristotle means we're mostly splitting hairs, while a 5 Aristotle ranking puts you in the same category as thinking the Earth sits at the center of the universe. Which, yes, Aristotle actually believed that too. Here's the thing though, these space myths aren't just spreading through dusty textbooks anymore. They're going viral on TikTok faster than you can say, cosmic vacuum cleaner. Instagram influencers with millions of followers are posting dramatic space content that looks amazing, but gets the science completely backwards. YouTube Shorts are packaging these misconceptions into bite-sized chunks that people consume and share without thinking twice. A single viral video claiming black holes suck everything in can reach 50 million people in a week, and most of those viewers will never see a correction. The stakes have never been higher for getting this stuff right. SpaceX is launching Falcon 9 rockets almost every week now, making space feel routine in a way that would have been unimaginable just 5 years ago. NASA's Artemis program is actively preparing to put humans back on the moon, with Artemis 3 targeting a lunar landing in the next few years. Private space tourism isn't science fiction anymore. It's something wealthy people actually do for vacation. Blue Origin and Virgin Galactic are selling tickets to space like their airline flights. When space exploration moves from government monopoly to commercial reality, these myths stop being harmless trivia mistakes. They become genuine barriers to public understanding of an industry that's reshaping our world. How can people make informed decisions about space policy, support space education, or even consider careers in aerospace when their baseline understanding is fundamentally wrong? We're tackling 8 major myths today, and here's what makes this list different from previous years. These aren't just the classic misconceptions that have been around since the space race. Some of these myths have evolved as our technology improved. Others have gotten worse because of how Hollywood depicts space travel. A few have emerged entirely new since commercial space exploration took off. The common thread is that they're all thriving in 2025's information ecosystem. Some of these myths sound completely reasonable when you first hear them. They follow logical patterns that make intuitive sense, which is exactly why millions of people believe them without question. The myth about which planet is hottest seems obvious when you think about distance from the sun. The idea that space is completely silent makes perfect sense if you remember that sound needs air to travel. These aren't stupid beliefs. They're smart conclusions based on incomplete information. But here's where it gets interesting. One of the myths we're covering today is so spectacularly wrong that it actually breaks our 5-point scale. We're talking about a misconception that's not just incorrect, but backwards in every meaningful way. It's like believing that ice is hotter than fire, or that gravity pushes things away from the Earth instead of pulling them toward it. The worst part is watching how Hollywood and social media influencers have made several of these myths significantly worse over the past few years. Movies need dramatic tension, so they exaggerate space dangers to impossible levels. Social media creators need engagement, so they post the most visually striking version of space phenomena, even when it's completely inaccurate. The algorithm rewards content that gets reactions, not content that gets the science right. What really gets under my skin is that some of these myths are being spread by sources that should know better. Educational websites sometimes oversimplify concepts to the point where they become wrong. Science museums create exhibits that prioritize visual impact over accuracy. Even NASA's own public communications sometimes use shorthand explanations that technically aren't correct, though they're trying to make complex physics accessible to general audiences. This creates a perfect storm where people encounter these myths from multiple sources that seem credible. They hear the same wrong information from a movie, a museum display, a viral TikTok, and a science textbook that's trying to simplify concepts. By the time they encounter the actual correct explanation, they've been exposed to the myth so many times that it feels like established fact. The good news is that understanding the real science behind these phenomena is actually more interesting than the myths. Black holes don't need to be cosmic vacuum cleaners to be fascinating. Their actual behavior is far weirder and more complex. The moon's phases become more beautiful when you understand what you're actually seeing each night. Astronauts floating in the space station are participating in one of the most elegant demonstrations of orbital mechanics in human history. By the end of this video, you'll have the knowledge to spot these myths when you encounter them online. More importantly, you'll understand the real science well enough to explain it to others. In an era where space misinformation spreads faster than scientific literacy, that makes you part of the solution. Some of these corrections might surprise you. The myth about dying in space, for example, has created unnecessary fear about space travel that could actually impact public support for space exploration. The misconceptions about planetary colors affect how people interpret images from Mars rovers and other space missions. Getting these facts straight isn't just academic. It's practical knowledge for living in a world where space is becoming part of everyday life. Here's what we're starting with: a myth that roughly 90% of people get wrong about the most famous and mysterious objects in space. These cosmic phenomena have captured human imagination for decades, spawned countless movie plots, and become the subject of more misconceptions than almost any other space topic. Black holes, the universe's most misunderstood monsters. Black holes earn that distinction because they don't actually suck anything. They're not cosmic vacuum cleaners roaming the galaxy and devouring everything in their path. This might be the most widespread space myth of 2025, and it's gotten significantly worse thanks to people rewatching Interstellar on Netflix during quarantine periods. The movie's dramatic visuals of the black hole Gargantua pulling in massive chunks of ice and debris have created this image of black holes as hungry monsters that reach across space to grab whatever they can find. The myth has exploded on TikTok and Instagram, where creators post videos showing black holes as swirling vortexes that somehow pull spaceships toward them from impossible distances. These videos rack up millions of views because they tap into our primal fear of being consumed by something we can't escape. The algorithm loves dramatic space content, so these misconceptions get pushed to more and more people who share them without checking whether they're actually accurate. What's really happening with black holes is much more mundane than Hollywood would have you believe. Black holes have something called an event horizon, which is basically the point of no return. But here's the key part. You'd have to get incredibly close to that event horizon before the black hole's gravity would affect you any differently than any other massive object in space. We're talking about distances measured in kilometers, not the light years that separate most objects in space. Think about it this way. If someone replaced our sun with a black hole that had exactly the same mass, Earth's orbit wouldn't change at all. We'd keep circling at the same distance, taking the same 365 days to complete one orbit. The only difference would be that we'd freeze to death because black holes don't emit light like stars do. But gravitationally speaking, nothing would change. Earth wouldn't get sucked into the black hole any more than it currently gets sucked into the sun. The James Webb Space Telescope discoveries have actually made the myth worse in some ways. JWST has been finding supermassive black holes in the early universe that are way bigger than we expected them to be. Science news articles about these discoveries often use dramatic language about black holes, consuming galaxies, or devouring matter, which reinforces the vacuum cleaner image. The reality is that these supermassive black holes are sitting at the centers of galaxies, and their gravity helps hold the entire galaxy together. They're not destroying their host galaxies. They're essential parts of how galaxies form and evolve. The better way to think about black holes is like a massive bowling ball sitting on a trampoline. If you roll a marble near the bowling ball, it might orbit around the heavy object for a while, or it might shoot past and continue on its way. Only if you roll the marble directly toward the bowling ball, or if it loses energy and spirals inward, will it actually hit the bowling ball. Black holes work the same way. Their gravity creates a deep well in space-time, and objects can orbit around that well safely for billions of years without getting consumed. Recent research from the Event Horizon Telescope has actually shown us exactly how matter behaves around real black holes. The EHT team has been improving their techniques since they captured that first historic image of the M87 black hole in 2019. Their newer observations show matter swirling around black holes in organized patterns, forming what's called an accretion disk. This matter isn't being sucked in randomly. It's following predictable orbital mechanics, just like planets around a star. Some of that matter does eventually cross the event horizon, but most of it gets heated up and ejected back into space as high-energy jets. This is the complete opposite of the Hollywood version, where black holes reach out and grab spaceships from light years away. The gravitational effects of a black hole follow an inverse square law, just like any other massive object. Double the distance, and the gravitational pull becomes 4 times weaker. At the distances where most space travel happens, a black hole's gravity is no more dangerous than a regular star of the same mass. NASA's upcoming black hole observation missions prove this point perfectly. The agency is planning multiple missions to study black holes up close, including potential orbiting observatories that would spend years examining the matter and energy around these objects. None of these mission planners are worried about their spacecraft getting sucked in, because they understand that you can study a black hole safely from a reasonable distance. Even the language we use to describe black holes makes this myth worse. We say that black holes consume matter or devour stars, when what we really mean is that matter crosses the event horizon and can't send information back to us about what happens next. The black hole isn't actively hunting for food like some cosmic predator. It's just sitting there being massive, and occasionally stuff falls into it following the same gravitational laws that govern everything else in the universe. The Event Horizon Telescope's work has been crucial in showing us what actually happens around black holes. Instead of seeing matter getting violently sucked in from all directions, we see organized structures. Magnetic fields channel matter into specific patterns. Some material gets accelerated to incredible speeds and shoots away from the black hole in jets that can extend for thousands of light years. This isn't the behavior you'd expect from a cosmic vacuum cleaner that indiscriminately pulls in everything around it. So we're giving this myth 4 Aristotles. The gravity is absolutely real, and black holes are definitely dangerous if you get too close. But the idea that they're cosmic vacuum cleaners that suck in everything around them is completely backwards from how gravity actually works. Speaking of things that are backwards from what most people think, our next myth involves something we actually look at every single night. The moon's dark side isn't what you think. The moon carries one of the most persistent misconceptions in all of space science. Here's something that will mess with your head. We can actually see the moon's dark side from Earth. In fact, we see it every single month. You're probably thinking I've lost my mind, but stick with me here. The problem is that people mix up 2 completely different concepts. There's the dark side, which is simply whichever half of the moon isn't lit up by the sun at any given moment. Then there's the far side, which is the half of the moon we never see from Earth. These are totally different things, but somehow they've gotten mashed together in people's minds. This confusion has gotten significantly worse in 2025, and we can thank China's Chang'e missions for part of that. When Chang'e 4 became the first spacecraft to land on the far side of the moon back in 2019, news outlets went crazy with headlines about exploring the dark side. Then, Chang'e 6 successfully returned samples from the far side in 2024, generating even more dramatic coverage. Social media exploded with posts about humanity finally reaching the mysterious dark side of the moon, and millions of people shared these posts without understanding that the terminology was completely wrong. The viral TikTok and Instagram posts about lunar exploration have made this worse by using dramatic language and visuals that reinforce the misconception. Creators post videos with ominous music talking about the mysterious dark side that humans have never seen, when in reality we photograph the far side regularly with lunar orbiters. The algorithm pushes this content because it sounds mysterious and exciting, so more people see the wrong information than the corrections. Let me break down the lunar phases to show you when we're actually looking at the dark side. During a new moon, when the moon appears completely invisible in our sky, we're actually staring directly at the dark side. The half of the moon facing us isn't getting any sunlight at all, it's completely dark. Meanwhile, the far side of the moon, which we can never see from Earth, is fully illuminated by the sun during a new moon. So the dark side that we're looking at is actually the near side, the same hemisphere we always see. As the moon goes through its phases, different portions of the near side get illuminated. During a first quarter moon, half of the near side is lit up and half is dark. We're seeing part of the dark side and part of the illuminated side at the same time. When we get to a full moon, the entire near side is lit up by the sun, so we're not seeing any of the dark side at all. The dark side during a full moon is the far side, the hemisphere we never see. Pink Floyd definitely didn't help matters with their 1973 album, The Dark Side of the Moon. The album cover shows a prism splitting white light into a rainbow, which has nothing to do with lunar physics, but the title has cemented this misconception in popular culture. Generations of people have grown up thinking there's some mysterious, permanently dark region of the moon that we've never explored. The reason we never see the far side has nothing to do with darkness and everything to do with the moon's rotation. The moon is tidally locked to Earth, which means it rotates on its axis at exactly the same rate that it orbits our planet. This synchronous rotation keeps the same hemisphere pointed toward Earth at all times. It's like if you walked in a circle around a friend while always facing them. They'd never see your back, but that doesn't mean your back is permanently dark. NASA's Artemis program is going to help clear up this confusion by exploring both sides of the moon. Artemis 3 is targeting a landing near the moon's south pole, while future missions will venture to other regions including areas we've never visited in person. When astronauts start posting photos and videos from different lunar regions, it'll become obvious that the far side gets just as much sunlight as the near side. The far side of the moon isn't permanently dark, mysterious, or hidden from human observation. We've been photographing it since 1959, when the Soviet Luna 3 probe first captured images of the far hemisphere. Every lunar orbiting mission since then has provided detailed maps and photographs of the entire lunar surface. The Lunar Reconnaissance Orbiter has been circling the moon since 2009, taking high-resolution images of both sides continuously. Private lunar missions in 2025 are also helping correct this misconception. Companies like Intuitive Machines have been delivering scientific payloads to various lunar locations, including regions that are sometimes on the dark side during their missions. When these landers send back images and data during lunar night conditions, it becomes clear that dark just means not currently illuminated by the sun. The terminology confusion is honestly understandable. When people hear dark side of the moon, it's natural to think of some permanently shadowed region that we've never explored. The phrase sounds poetic and mysterious, which is probably why it stuck around for so long. But the physics is actually pretty straightforward once you understand that the moon's rotation and orbit are synchronized. So we're giving this myth 3 Aristotles. The terminology confusion is genuinely understandable, and the concept of tidal locking isn't immediately obvious. But the physics behind lunar phases and the moon's rotation is well-established science that people can observe for themselves just by watching the moon change shape throughout the month. Speaking of observing things for yourself, our next myth involves something that millions of people watch live on NASA's cameras every single day, yet somehow still get completely wrong about what they're actually seeing. Astronauts don't float because of zero gravity. Those live feeds show astronauts floating around the International Space Station. But here's something that's going to completely flip your understanding of space travel. There's no such thing as zero gravity up there. None. The astronauts floating around are experiencing roughly 90% of Earth's gravity at their altitude. They haven't escaped our planet's gravitational pull at all. This might be the most persistent space myth of 2025. And it's one that even NASA has accidentally reinforced for decades through their own language choices. The ISS orbits about 400 kilometers above Earth's surface, which sounds like a huge distance until you realize that Earth's radius is over 6,000 kilometers. At that altitude, Earth's gravity is only about 10% weaker than what we experience on the ground. If you could somehow build a tower that tall and stand on top of it, you'd still feel almost the same gravitational pull that you feel right now. The astronauts aren't floating because they've escaped gravity. They're floating because they're in a state of continuous free fall. Think of it like being in an elevator that's constantly falling, except the elevator never hits the ground. You know that moment on a roller coaster when you go over the highest hill and your stomach drops because you feel weightless for a split second? That's exactly what astronauts experience, except it never stops. They're falling toward Earth at the same rate as their spacecraft, so they float relative to everything around them. The sensation is identical to zero gravity, but the physics explanation is completely different. This misconception has gotten worse in 2025 because of how commercial spaceflight companies market their experiences. Blue Origin's New Shepard flights take passengers on suborbital trips that provide about 4 minutes of weightlessness. Virgin Galactic's Spaceship Two offers similar suborbital experiences with brief periods of floating. These companies market their flights as zero-gravity experiences, which technically describes what passengers feel, but it reinforces the myth about what's actually happening. The difference between these commercial flights and orbital spaceflight is huge. Blue Origin and Virgin Galactic customers experience weightlessness because their spacecraft reach the top of a ballistic arc like throwing a ball really high in the air. For a few minutes, both the passengers and the spacecraft are falling back toward Earth at the same rate, creating that weightless sensation. But then they land and gravity wins. Orbital spaceflight is completely different because the spacecraft is moving so fast horizontally that it keeps missing the ground as it falls. NASA deserves some blame for spreading this myth through decades of their own communications. They've used terms like zero-G and microgravity to describe conditions on the space station, even though these terms are technically inaccurate. The agency started using this language because it's easier for the public to understand than explaining orbital mechanics and continuous free fall. But the simplified explanation has become so widespread that most people now believe astronauts have actually escaped Earth's gravity. Understanding what's really happening up there matters for the scientific research being conducted on the ISS in 2025. Experiments designed to study how materials behave in the absence of gravity need to account for these tiny residual forces. Protein crystal growth experiments, metal alloy research, and fluid physics studies all depend on understanding the true microgravity environment. If researchers assumed there was literally zero gravity, their experimental designs would be flawed from the start. The continuous free-fall environment affects human physiology in specific ways that wouldn't happen in true zero gravity. Astronauts experience bone loss and muscle atrophy because their bodies don't have to work against gravity to maintain posture and move around. But they also deal with fluid shifts as blood and other body fluids redistribute without gravity's constant downward pull. These effects are directly related to being in free fall, not to the absence of gravitational force. The myth that astronauts need to escape Earth's gravity is particularly problematic because it misrepresents how orbital mechanics actually work. Astronauts aren't trying to get away from Earth's gravity. They're using it to stay in orbit. The gravitational force is what keeps the ISS circling our planet instead of flying off into deep space. Without Earth's gravity constantly pulling the station toward the planet's center, the ISS would travel in a straight line and leave Earth's vicinity entirely. The physics of orbital mechanics explains why the ISS needs periodic boosts to maintain its altitude. Even at 400 kilometers above Earth's surface, there are still trace amounts of atmosphere creating tiny amounts of drag on the station. This atmospheric drag gradually slows down the ISS, which lowers its orbit and brings it closer to Earth. Without regular boosts from visiting spacecraft or the station's own thrusters, the ISS would eventually fall back to Earth within a few years. Recent ISS research in 2025 has taken advantage of the true microgravity environment to study phenomena that would be impossible to observe on Earth's surface. Experiments with combustion in microgravity have revealed how flames behave without buoyancy effects. Materials science research has produced metal alloys with properties that can't be achieved in Earth's gravitational field. These experiments work because researchers understand the real conditions aboard the station, not because they assume there's no gravity at all. So we're giving this myth 4 Aristotles. While the experience genuinely feels like zero gravity, and the effects on the human body and scientific experiments are similar to what you'd expect in true zero gravity, the physics explanation is completely different from what most people believe. Speaking of things that look completely different from what people expect, our next myth involves something that changes appearance so dramatically that even spacecraft orbiting it send back images that surprise mission scientists. Mars isn't actually red, and other planetary color myths. Mars provides the perfect example of this phenomenon. The planet isn't actually red, at least not in the way most people picture it. Mars' color changes dramatically depending on atmospheric conditions, viewing angle, and even the time of day. This might sound impossible given that we've been calling it the red planet for centuries, but Mars appears different colors all the time. Sometimes it looks butterscotch, sometimes dusty orange, sometimes almost tan. The consistent rust-red image that exists in most people's minds is a major oversimplification of a much more complex reality. The 2025 images from NASA's Perseverance rover have been particularly revealing about Mars' true colors. When the rover's cameras capture images in natural lighting conditions without any color enhancement, Mars often appears more butterscotch than red. The soil samples and rock formations show a rich variety of colors ranging from light tan to deep brown, with reddish tones mixed throughout rather than dominating the entire landscape. These true color images look nothing like the dramatic red desert planet that most people expect to see. The reason we see Mars as red from Earth involves a combination of atmospheric scattering and the iron oxide that's genuinely present on the planet's surface. When sunlight hits Mars, the iron oxide particles in the dust and soil absorb blue light and reflect red wavelengths back toward us. Earth's own atmosphere then scatters some of those wavelengths as the light travels the millions of miles between the two planets. By the time that light reaches our eyes or telescopes, the red wavelengths dominate what we can see. But this process doesn't mean the entire planet is uniformly red when you're actually standing on its surface. Instagram and TikTok have made this color misconception significantly worse in 2025. Social media creators post Mars images with heavy filters and color saturation adjustments that make the planet look like a dramatic red wasteland. These enhanced images get millions of views because they look striking and otherworldly, but they're completely inaccurate representations of what Mars actually looks like. The algorithm pushes visually dramatic content, so the most oversaturated and unrealistic Mars images spread faster than the accurate ones from NASA's rovers. The broader myth about planetary colors extends way beyond Mars. People expect Jupiter to always show those famous swirling bands of color, but the gas giant's appearance changes constantly as its atmospheric storms move and evolve. The Great Red Spot has been shrinking for decades, and its color has shifted from deep red to more of an orange-pink. Saturn's rings aren't always visible from Earth. They appear edge-on every 14-15 years and basically disappear from our view. Hollywood deserves significant blame for reinforcing the rust-red Mars stereotype. Movies consistently portray the planet as a uniform red desert with dramatic red lighting that makes everything look like it's bathed in blood. Films like The Martian and Total Recall show Mars as relentlessly red in every single scene, which creates this expectation that the entire planet looks the same everywhere you go. The reality is much more varied, with different geological features showing completely different color palettes depending on their composition and age. Recent atmospheric data from Mars gathered in 2025 shows that the planet experiences significant seasonal color changes. During dust storm seasons, Mars can appear much redder as fine particles get kicked up into the atmosphere and scatter light differently. When the dust settles, the planet's surface reveals more of its natural color variation. Ice caps at the poles create bright white patches that contrast sharply with the surrounding terrain. These seasonal changes prove that Mars doesn't have a single consistent color. The most shocking color fact about Mars is that Martian sunsets are actually blue, not red like the ones we see on Earth. This happens because of how sunlight scatters in Mars' thin atmosphere. The dust particles in the Martian atmosphere are just the right size to scatter blue light more effectively during sunset conditions. So while we're used to seeing red and orange sunsets on Earth, an astronaut standing on Mars would watch the sun set in shades of blue and purple. This is the complete opposite of what most people would expect from the red planet. The iron oxide explanation for Mars' color isn't wrong, but it's incomplete. Iron oxide is definitely present in Martian soil and contributes to reddish coloring in many regions. However, Mars also contains olivine, pyroxene, and other minerals that create different colors. Some areas of the planet are rich in darker volcanic rocks that appear almost black. Other regions contain lighter-colored sediments that look tan or beige. The distribution of these different minerals across Mars' surface creates a complex color palette that can't be summarized as simply red. The color variations on Mars also tell us about the planet's geological history. Regions with more iron oxide formed under different conditions than areas with other mineral compositions. Some colors indicate ancient water activity, while others suggest volcanic processes or meteor impacts. Understanding Mars' true color palette helps scientists interpret the planet's past and identify locations where life might have once existed. So we're giving this myth 3 Aristotles. Mars definitely contains iron oxide and does appear reddish when viewed from Earth under certain conditions. But the idea that it's a uniformly red planet everywhere you look is a significant oversimplification that ignores the complex and varied reality of Martian geology and atmospheric conditions. Speaking of things that look completely different depending on your viewing perspective, our next myth involves something that billions of people believe they can see from space, but astronauts who are actually up there keep insisting is completely invisible. The Great Wall of China Space Visibility Hoax. The Great Wall of China represents the most persistent visibility myth in all of space science. This misconception has actually gotten significantly worse in 2025, and we can blame high-resolution satellite imagery getting misinterpreted all over social media for that. TikTok creators and Instagram influencers keep posting Google Earth screenshots showing the Great Wall and claiming you can see it from space with your naked eye. These posts get millions of views because they tap into this sense of national pride and human achievement. The problem is that these satellite images use specialized equipment and heavy image enhancement to make the wall visible in the first place. Astronauts have repeatedly confirmed that you absolutely cannot see the Great Wall from space without assistance. We're not talking about one or two astronauts making offhand comments either. This has been consistently reported by crew members from multiple countries over decades of space missions. Current ISS crew members in 2025 continue to debunk this myth whenever they get asked about it during live streams and educational events. They've tried looking for the wall during their orbital passes over China, and they simply can't distinguish it from the surrounding landscape with their unaided eyes. The physics behind this makes perfect sense once you break it down. The Great Wall is roughly 6 meters wide on average, which sounds substantial until you realize that astronauts on the ISS are orbiting about 400 kilometers above Earth's surface. From that distance, the wall appears as a thin line that's narrower than a human hair held at arm's length. Even worse, the wall is built from stone and brick materials that blend almost perfectly with the natural colors of the surrounding mountains and desert terrain. There's no sharp contrast that would make it stand out against the background. Google Earth and commercial satellite imagery have created massive confusion about what humans can actually see from space. These platforms use satellites equipped with powerful cameras, specialized lenses, and computer processing that enhances contrast and sharpens details. When you zoom in on the Great Wall using Google Earth, you're not seeing what an astronaut would see with their naked eye. You're seeing the result of advanced imaging technology, specifically designed to reveal surface features that would otherwise be invisible. What astronauts can actually see from space tells us everything about why the Great Wall isn't visible. They can easily spot city lights at night because artificial lighting creates a stark contrast against the dark landscape. They can see large rivers because water reflects sunlight differently than surrounding land. Deforestation patterns show up clearly because cleared land has different colors and textures than forested areas. These features work because they're either very large, very bright, or create strong visual contrast with their surroundings. The Great Wall has none of these characteristics. Commercial satellite imagery in 2025 has reached incredible resolution capabilities, with some satellites able to distinguish objects smaller than a meter across. Even with this advanced technology, massive structures like highways, airports, and large buildings are barely visible without digital enhancement. Companies like Planet Labs and Maxar operate satellite constellations that can photograph the entire Earth's surface daily, but they rely on computer processing to make most human-made features distinguishable in their images. The nationalist pride aspect of this myth has always bothered me because it suggests that visibility from space somehow measures a structure's importance or impressiveness. The reality is that many countries have built massive, incredible structures that aren't visible from space either. The interstate highway system in the United States covers way more area than the Great Wall, but you can't see individual highways from orbit. The pyramids in Egypt are impressive feats of engineering, but they're not visible from space without enhancement. Russia's Trans-Siberian Railway stretches across an entire continent, but it's not visible either. Current astronauts on the ISS spend their time photographing completely different things than what most people expect. They focus on weather patterns like hurricanes and storm systems that span hundreds of kilometers. They photograph geological formations like mountain ranges, river deltas, and volcanic activity. They document environmental changes like glacier retreat, urban expansion, and seasonal changes in vegetation. These are the phenomena that actually stand out when you're looking down at Earth from orbit. The photography equipment that astronauts use reveals another layer to this misconception. When ISS crew members take those stunning Earth photos that go viral on social media, they're using professional cameras with powerful telephoto lenses. These cameras can zoom in on specific features and capture details that wouldn't be visible to the naked eye. Even with this professional equipment, astronauts have to know exactly where to look and when to look to capture specific landmarks. Social media has made this myth significantly worse by spreading enhanced satellite imagery without proper context. People see these processed images and assume they represent what humans would actually see from space. The images get shared millions of times with captions claiming the Great Wall is visible from orbit, but nobody explains that the images have been digitally enhanced to make the wall stand out. The persistence of this myth demonstrates how misconceptions can survive despite repeated debunking by credible sources. Astronauts, NASA, space agencies from multiple countries, and physics experts have all confirmed that the Great Wall isn't visible from space. Yet the myth continues to spread because it sounds impressive and taps into people's sense of wonder about human achievement. So we're giving this myth a full 5 Aristotles because it's completely, demonstrably false and has been repeatedly debunked by the people who are actually up there looking down at Earth every day. Speaking of things that look completely different from orbit than most people imagine, there's another space misconception that Hollywood has made infinitely worse by turning empty regions of space into dramatic obstacle courses. Asteroid belts aren't dense minefields. Asteroid belts represent the complete opposite of those dramatic space obstacle courses. You know the scene: spaceships weaving frantically between massive rocks, pilots sweating as they dodge collision after collision, dramatic music building as the heroes barely escape getting smashed to pieces. It's pure fiction, and it's the complete opposite of how asteroid belts actually work in the real universe. Spacecraft routinely fly through the asteroid belt without any special navigation whatsoever. They don't need evasive maneuvers, they don't need special shielding, and mission controllers don't lose sleep worrying about collisions. The asteroid belt between Mars and Jupiter is mostly empty space, so empty that the chances of accidentally hitting an asteroid are basically zero. Every Mars mission since the 1960s has passed through the asteroid belt as part of its normal flight path, and none of them have ever needed to dodge asteroids like some cosmic video game. The 2025 asteroid mining missions prove this point perfectly because they have to work incredibly hard just to reach a single asteroid. These missions require years of planning, precise trajectory calculations, and careful timing to intercept one specific space rock. If asteroid belts were the dense minefields that Hollywood portrays, asteroid mining would be trivial. You just fly into the belt and start scooping up rocks. Instead, companies like Astroforge have to target individual asteroids with surgical precision because they're separated by enormous distances. The numbers behind asteroid belt density will blow your mind. The typical distance between asteroids in the main belt is millions of kilometers. We're not talking about thousands or even hundreds of thousands. We're talking about distances larger than the space between Earth and the Moon. If you were sitting on one asteroid in the belt, you'd need a powerful telescope just to see the next closest one. Most of the time, you wouldn't be able to see any other asteroids at all with your naked eye. The best way to understand asteroid belt density is to imagine throwing a handful of pebbles across an entire football stadium. Now imagine that the stadium extends upward for several miles and downward into the ground for several more miles. That handful of pebbles scattered through that enormous three-dimensional space represents the actual density of objects in the asteroid belt. The chances of two pebbles being anywhere near each other are essentially zero. NASA's asteroid redirect missions demonstrate just how sparse these regions really are. These missions involve sending spacecraft to rendezvous with specific asteroids, sometimes spending years in transit to reach their targets. The OSIRIS-RX mission traveled for over 2 years just to reach the asteroid Bennu, and mission planners had to calculate its trajectory with incredible precision to make the rendezvous work. If asteroids were densely packed like Hollywood suggests, these missions would be simple. Just fly toward the general area and pick whichever asteroid looks most convenient. Current commercial space ventures planning asteroid mining operations highlight just how challenging it is to reach even a single asteroid. Companies developing asteroid mining technology have invested millions of dollars in systems needed to identify, approach, and extract materials from individual asteroids. These companies wouldn't exist if asteroids were easy to find and access. The entire business model of asteroid mining depends on the fact that certain asteroids contain valuable materials, but reaching those specific asteroids requires dedicated missions and enormous investments. The communication challenges faced by asteroid missions further prove how isolated these objects are. Astroforge's Brocker 2 mission, which launched in February 2025, was designed to perform a flyby of a near-Earth asteroid to determine if it was metallic. The mission unfortunately failed due to communication issues, which highlights how difficult it is to maintain contact with spacecraft operating in the sparse environment around asteroids. The spacecraft has to arrive at exactly the right place at exactly the right time to encounter its target asteroid. There's no room for error and no backup options if something goes wrong. Real asteroid belt navigation is so uneventful that mission controllers barely think about it. When NASA sends a spacecraft to Mars, the asteroid belt crossing is just another routine part of the journey. The spacecraft follows a predetermined path calculated months or years in advance, and it passes through the belt without any drama whatsoever. The most exciting thing that happens is that mission controllers sometimes take pictures of distant asteroids, if any happen to be visible along the flight path. The European Space Agency's asteroid missions follow the same pattern. The Rosetta mission spent 10 years traveling to Comet 67P, passing through the asteroid belt twice during its complex trajectory. ESA mission planners didn't design special asteroid avoidance systems or develop evasive maneuver capabilities. They calculated a path that would take Rosetta exactly where it needed to go, and the spacecraft followed that path without encountering any obstacles. The physics of asteroid formation explains why they're so widely separated. When the solar system formed, the gravitational influence of Jupiter prevented the material in the asteroid belt region from coalescing into a single planet. Instead, that material remained scattered as individual objects orbiting the Sun at different distances and speeds. Jupiter's gravity continues to influence asteroid orbits today, but it spreads them out rather than clustering them together. So we're giving this myth a full 5 Aristotles because the Hollywood version represents the complete opposite of reality. Asteroid belts aren't obstacle courses. They're vast regions of mostly empty space, with occasional rocks scattered at enormous distances from each other. Speaking of things that seem obvious but turn out to be completely wrong when you look at the actual science, there's another myth about our solar system that trips up almost everyone because it seems so logical based on a simple rule about distance. Mercury isn't always the hottest planet. Venus holds the title for hottest planet in our solar system, not Mercury. This counterintuitive fact surprises people because the logic seems so straightforward. Mercury orbits closest to the Sun, so it should be the hottest, right? Wrong. Venus maintains surface temperatures that reach 900 degrees Fahrenheit, which is hot enough to melt lead. Meanwhile, Mercury's surface temperatures swing wildly between blazing hot and freezing cold, depending on which side faces the Sun. The difference comes down to atmosphere. And it's a perfect example of how simple assumptions about space can be completely backwards. This myth persists in 2025 despite decades of planetary science education. And you can blame textbooks that oversimplify planetary characteristics for part of the problem. Elementary school science books often list planets in order of distance from the Sun alongside their basic properties, which creates this mental connection between proximity and temperature. Students learn that Mercury is first, Venus is second, and they naturally assume that the order of distance matches the order of heat. Teachers sometimes reinforce this misconception by not explaining the role of atmospheric conditions in planetary temperatures. The real explanation involves Venus's incredibly thick atmosphere, which creates what scientists call a runaway greenhouse effect. Venus's atmosphere is roughly 96% carbon dioxide, and it's about 90 times denser than Earth's atmosphere. When sunlight hits Venus, the energy gets trapped by all that carbon dioxide and can't escape back into space. The result is a planet-wide oven that maintains consistent temperatures across the entire surface, day and night. The greenhouse effect on Venus is so extreme that the planet's surface is hotter than Mercury's sun-facing side. Climate scientists in 2025 frequently reference Venus when discussing the potential consequences of unchecked atmospheric carbon dioxide on Earth. Venus serves as the ultimate cautionary tale for what happens when greenhouse gases reach extreme concentrations. The planet probably wasn't always this hot. Scientists believe Venus might have had liquid water billions of years ago, before the runaway greenhouse effect took over. As Earth's atmospheric CO2 levels continue rising, Venus represents the worst-case scenario for planetary climate change. Mercury's temperature situation is completely different because it has essentially no atmosphere to speak of. The planet's extremely thin atmosphere can't trap heat effectively, so temperatures depend entirely on direct exposure to sunlight. The sun-facing side of Mercury reaches temperatures of about 800 degrees Fahrenheit, while the dark side drops to negative 300 degrees Fahrenheit. These extreme temperature swings happen because Mercury rotates very slowly. One day on Mercury lasts about 59 Earth days. Parts of the planet spend weeks in blazing sunlight followed by weeks in freezing darkness. The 2025 exoplanet discoveries have revolutionized how astronomers classify hot planets in other solar systems. When scientists find exoplanets orbiting close to their stars, they can't assume these worlds are the hottest in their systems without understanding their atmospheric conditions. The James Webb Space Telescope has been analyzing exoplanet atmospheres and finding that some planets farther from their stars are actually hotter than closer ones, just like Venus and Mercury in our solar system. The simple closer equals hotter logic seems so intuitive that even smart people fall for it. The misconception makes perfect sense if you think about standing next to a campfire. The closer you get, the hotter you feel. But planetary temperatures don't work like campfires because planets have atmospheres that can trap or release heat in complex ways. Mercury receives about 7 times more solar energy per square meter than Earth does, but it can't hold onto that energy without an atmosphere to trap it. Venus receives only twice as much solar energy as Earth, but its thick atmosphere amplifies that energy into extreme heat. Several space agencies have proposed new Venus missions for the late 2020s, partly because understanding Venus's extreme greenhouse effect has become more relevant as Earth's climate changes. NASA's Debunking mission is planned to study Venus's atmosphere in unprecedented detail, while the VERITAS mission would map the planet's surface using radar. These missions matter because Venus represents what can happen when atmospheric greenhouse gases reach extreme levels. This misconception significantly affects public understanding of planetary habitability and climate science. When people believe that distance from a star determines temperature, they misunderstand how scientists evaluate potentially habitable exoplanets. The habitable zone around a star isn't just about distance. It's about the complex interaction between stellar radiation, atmospheric composition, and planetary characteristics. Venus technically sits within the Sun's habitable zone, but its runaway greenhouse effect makes it completely uninhabitable. The atmospheric physics explanation also helps people understand why Mars is so cold despite being relatively close to the Sun. Mars has a very thin atmosphere that can't trap heat effectively, so it stays cold even though it receives substantial solar energy. The planet's average temperature is about -80 degrees Fahrenheit, which demonstrates that atmospheric density matters as much as distance from the Sun. Mercury's lack of atmosphere creates other interesting effects beyond extreme temperature swings. The planet has no weather because weather requires atmospheric circulation. There are no seasons because seasonal changes depend on atmospheric conditions changing over time. There's no protection from radiation or meteorite impacts because atmospheres normally provide shielding from these hazards. So we're giving this myth 4 Aristotles because while Mercury is genuinely closer to the Sun and does receive more solar energy, atmospheric physics completely overwhelms the effects of distance. The intuitive logic makes sense until you understand how atmospheres work. But once you factor in greenhouse effects and heat retention, the distance-based assumption becomes totally wrong. Speaking of atmospheric effects that most people completely misunderstand, there's another space myth that's been shattered by some surprising discoveries that space agencies made in 2025. Space isn't silent, the sound myth that won't die. NASA's 2025 recordings from the Perseus Galaxy Cluster black hole completely demolished the idea that space is absolutely silent. These aren't simulated sounds or artistic interpretations. They're actual sound waves that were captured and translated into frequencies we can hear. This discovery forces us to reconsider one of the most famous taglines in science fiction history. In space, "No one can hear you scream" became iconic thanks to the 1979 movie Alien, and it's been repeated so many times that most people accept it as scientific fact. The tagline sounds perfectly logical because we know that sound needs a medium to travel through, and space is mostly vacuum. But space isn't completely empty, and that makes all the difference for whether sound can actually exist out there. The interstellar medium fills the space between stars with gas, dust, and plasma particles. These particles are incredibly sparse compared to Earth's atmosphere. We're talking about maybe 1 atom per cubic centimeter compared to billions of atoms in the same volume of air on Earth. But sparse doesn't mean non-existent, and those particles can absolutely transmit sound waves under the right conditions. NASA's Perseus black hole recording represents a major breakthrough in cosmic acoustics. The black hole at the center of this galaxy cluster creates pressure waves that ripple through the surrounding hot gas and plasma. These pressure waves are sound waves, just operating at frequencies way below what human ears can detect. NASA scientists took these ultra-low frequency sound waves and shifted them up by 57 and 58 octaves to make them audible to human ears. The result is this haunting, otherworldly sound that proves space isn't silent after all. The discovery has forced scientists to reconsider how sound behaves in different space environments. Dense regions like galaxy clusters have enough material to support sound transmission over enormous distances. The sound waves from the Perseus black hole have been traveling through the cluster's hot gas for tens of millions of years, creating ripples that span hundreds of thousands of light years. These aren't weak vibrations either. They're powerful pressure waves that carry enormous amounts of energy across cosmic distances. This myth has evolved significantly as we've learned more about plasma physics and the structure of space itself. Early space exploration reinforced the silence myth because astronauts outside their spacecraft couldn't hear each other talking. But we now understand that space contains different types of matter in different concentrations, and some of these environments can definitely support sound transmission. Solar wind carries charged particles throughout the solar system. Planetary magnetospheres trap and channel these particles. Nebulae contain dense clouds of gas and dust. All of these environments have enough material to transmit sound waves. Modern space missions in 2025 have given us practical examples of how sound works in space environments. Astronauts can absolutely hear each other when their helmets touch during spacewalks because sound travels through the solid material connecting their suits. The International Space Station creaks and groans as it expands and contracts during orbital temperature changes, and crew members can hear these sounds transmitted through the station's structure. Spacecraft instruments detect acoustic vibrations from thrusters, mechanical systems, and even the impact of tiny meteoroids on hull surfaces. The absolute version of the space silence myth falls apart when you consider that different regions of space have wildly different particle densities. The solar corona contains enough plasma to support sound waves, which is why scientists can study solar oscillations in stellar seismology. Planetary atmospheres extend much farther into space than most people realize, creating tenuous environments where sound can still propagate. Even the seemingly empty space between galaxies contains trace amounts of matter that could theoretically carry acoustic waves over cosmic timescales. Current research into space acoustics has revealed fascinating details about how sound behaves in extreme environments. Scientists study the acoustic properties of planetary rings, where countless particles collide and create complex wave patterns. They analyze how sound travels through comet tails as solar wind interacts with outgassed material. They investigate acoustic phenomena in stellar atmospheres where sound waves help transport energy from stellar cores to outer layers. The implications for 2025 space exploration are more significant than you might expect. Understanding how sound travels in different space environments helps engineers design better spacecraft systems and communication equipment. Knowing that certain regions of space can support acoustic transmission helps mission planners account for potential interference or signal propagation effects. The research also contributes to our understanding of how energy and information move through cosmic environments. Plasma physics has been particularly important for understanding space acoustics. Plasma behaves differently than ordinary gas because the particles are electrically charged, which creates additional ways for waves to propagate. Magnetohydrodynamic waves can carry acoustic energy through plasma environments across enormous distances. These plasma acoustic effects show up in solar wind interactions, auroral displays, and the behavior of matter around black holes and neutron stars. The recordings from space have also revealed that cosmic sound phenomena operate on completely different scales than anything we experience on Earth. The Perseus black hole sound waves have wavelengths measured in hundreds of thousands of light years. A single oscillation takes tens of millions of years to complete. These are sound waves that span entire galaxy clusters and persist for longer than complex life has existed on Earth. The myth persists partly because the conditions for sound transmission in space are so different from what we experience on Earth. Space sounds travel much more slowly than terrestrial sounds because the medium is so much less dense. The frequencies are often far outside the range of human hearing. The wavelengths can be enormous compared to anything we encounter in daily life. These differences make space acoustics seem impossible, even when the physics clearly shows that sound can exist in cosmic environments. So we're giving this myth 3 Aristotles because the absolute claim that space is completely silent is definitely wrong, but space is unquestionably much quieter than Earth in most locations. The myth gets the general idea right. You can't have a normal conversation in the vacuum of space, but it goes too far by claiming that sound is completely impossible in all space environments. Speaking of myths that go too far in the wrong direction, there's another space misconception that Hollywood has turned into something genuinely disturbing and completely backwards from reality. The explosive truth about dying in space. The explosive death myth represents Hollywood's most disturbing contribution to space misconceptions. Movies and TV shows love showing characters getting sucked out of airlocks and either bursting apart like balloons or instantly freezing into ice cubes. These dramatic death scenes are horrifying and memorable, which is exactly why they stick in people's minds as scientific fact instead of pure fiction. The space tourism industry's rapid expansion in 2025 has made these misconceptions particularly problematic for public safety understanding. Companies like Blue Origin and Virgin Galactic are selling tickets to ordinary people who have no space training, and many potential customers are genuinely terrified by Hollywood's version of what happens if something goes wrong. SpaceX's Fram 2 mission in April 2025 became the first crewed spaceflight to enter a polar retrograde orbit, demonstrating that commercial space travel is pushing into new territory with civilian passengers who need accurate safety information rather than movie special effects. What actually happens when a human gets exposed to space vacuum is far less dramatic, but still dangerous. You have roughly 15 seconds of useful consciousness before you pass out from lack of oxygen. That's enough time to potentially save yourself if you're near an airlock or emergency shelter, but not enough time for the theatrical death scenes that movies love to show. The loss of consciousness happens because your lungs can't extract oxygen from your bloodstream when there's no air pressure to keep your respiratory system functioning properly. The exploding human myth comes from a fundamental misunderstanding of how pressure works in biological systems. Your blood won't actually boil when exposed to vacuum because your circulatory system maintains internal pressure through the strength of your blood vessels and heart function. Think of your cardiovascular system like a closed pressure cooker. The liquid inside doesn't boil just because the external pressure drops, as long as the container maintains its integrity. Your blood vessels are strong enough to contain your blood at normal pressure, even in a complete vacuum. Current spacesuit emergency procedures used by 2025 astronauts and commercial space travelers are designed around the real dangers of vacuum exposure, not the Hollywood version. Emergency protocols focus on getting the person back to a pressurized environment as quickly as possible, usually within those critical 15 seconds of consciousness. Spacesuits have multiple backup systems precisely because engineers understand that vacuum exposure is survivable for short periods if handled correctly. The emphasis is on speed and maintaining life support systems, not on preventing the person from exploding. The instant freezing myth demonstrates another fundamental misunderstanding of how heat transfer works in space. Space is actually an excellent insulator because there's no matter to conduct heat away from your body. On Earth, you lose body heat through conduction to air molecules and convection as warm air rises away from your skin. In the vacuum of space, you can only lose heat through radiation, which is an extremely slow process. You'd actually overheat from your own body's heat production long before you'd freeze to death. Scientific studies and controlled experiments have provided detailed information about what really happens during vacuum exposure. Research using computer modeling has shown that consciousness is lost within 10 to 15 seconds, but biological functions can continue for several minutes before permanent damage occurs. These studies inform the development of space suit design, emergency procedures, and safety training programs. The research consistently shows that while vacuum exposure is serious, it's not the instantly fatal explosion that movies portray. Laboratory experiments with vacuum chambers have demonstrated exactly how biological tissues respond to rapid decompression. The experiments show that soft tissues do expand due to the pressure difference, but they don't rupture or explode because biological materials are much stronger than most people realize. The human body has evolved to handle significant internal pressure variations, which is why deep-sea divers can surface safely and why people can travel to high altitudes without exploding. The boiling saliva myth represents another aspect of this misconception that's technically true but practically irrelevant. Saliva will indeed boil on your tongue in a vacuum because it's exposed to the low-pressure environment. However, this doesn't cause the dramatic effects that people imagine. The saliva just bubbles and evaporates, similar to what happens when you put liquid in a vacuum chamber during a high school physics demonstration. It's weird and uncomfortable, but it's not the violent, destructive process that movies suggest. Current space tourism safety briefings in 2025 specifically address these misconceptions because passengers arrive with expectations based on science fiction rather than science fact. Safety instructors have to spend time debunking Hollywood myths before they can teach actual emergency procedures. This educational process is crucial because passengers need to understand real risks and real responses rather than panicking about imaginary explosive decompression scenarios. These Hollywood myths create unnecessary fear about space exploration that actually hurts public support for space programs. When people believe that space travel means instant death from any small mistake, they're less likely to support funding for space missions or consider space careers. The dramatic misconceptions make space seem impossibly dangerous when the real risks are manageable through proper engineering and safety procedures. Emergency medical procedures for vacuum exposure focus on treating decompression sickness and oxygen deprivation, rather than dealing with exploded or frozen bodies. Medical teams train for scenarios where someone might be exposed to vacuum for 30 seconds to a minute, which is completely survivable with proper treatment. The medical protocols prove that brief space exposure is a treatable emergency, not an automatic death sentence. So we're giving this myth 5 Aristotles because Hollywood's version is not just wrong, but dangerously wrong in ways that create unnecessary fear about space exploration and interfere with proper safety education. The real dangers of vacuum exposure are serious enough without inventing completely fictional explosive scenarios that have nothing to do with actual human physiology. The pattern here is becoming clear. These misconceptions share something important that explains why they're so hard to shake. These myths persist because they sound more dramatic or intuitive than the actual science. Black holes as cosmic vacuum cleaners feel scarier than gravitational physics. Exploding in space seems more theatrical than slow heat loss through radiation. The dark side sounds more mysterious than synchronized rotation. Before you share that next space video on TikTok or Instagram, check NASA's Moon Phase Simulator or browse the actual images from Mars rovers and space telescopes instead of relying on viral videos. These misconceptions matter because they create unnecessary fear about space exploration and prevent people from appreciating the genuinely fascinating reality of how the universe actually works. In 2025, as space becomes part of everyday life through commercial flights and regular launches, understanding the real science behind these phenomena isn't just academic curiosity. It's practical knowledge for the space age we're entering.